feasible successor. So now if the cost here is 40, then this path will have no backup path. Then look down. This is Cisco's metric. This 5K refers to 5 values. We haven't learned some settling yet. You can think of this K as it is 5 values. Assume that respectively the bandwidth, reliability, delay, load, maximum transmission unit. Then there are 2 values in each value. 0 and 1. 1 for reference. 0 means no reference. That is 1 for sure. 0 means negative. For EIGRP, it can refer to 5 parameters. Let's learn EIGRP for beginners. Only focus on 2. 1 is bandwidth. 1 is delayed. Usually. Reliability. Loading. And MTU. We often don't think about it. For OSPF, just refer to the bandwidth. EIGRP reference 5 options. If we refer to bandwidth, then this one is 1. If the reference delay, then it is 1. Others do not refer to 0. Then this 5K value is 10100. This means we refer to bandwidth and latency without reference to the other 3 parameters. 5K is 5 reference factors. Refers to the 5 values. By default, EIGRP only refers to bandwidth and delay. Others are not referenced. The following is the calculation formula of metric. Everyone can take a look. 256 times 10 to the 7th power divided by the minimum interface bandwidth of the link. Add the sum of link delays and divide by 10. So there are actually only bandwidth and latency in it. This is a default calculation formula. Therefore, we generally do not refer to other. 5K is 5 values. It represents the reference switch. Reference is 1. No reference is 0. When you reach the NP stage, you will learn the message. That is, all packets of EIGRP. You will both get packets. Then look at the fields one by one. Then you will see the values of 0 and 1 in this 5K are. Next look at the message. Let's not look at the 5th. In fact, the 5th is not a real message. There are 4 EIGRP packets. Hello, update, query, and reply. Hello is to establish a neighbor relationship. Hello packet. I just introduced it to you. If the 2 routers are now directly connected, once EIGRP is announced, the 2 interfaces will start sending hello packets to the outside world. They both send each other. Then one of the devices receives the other party's hello packet. The 2 of them will establish a neighbor relationship. They start to learn routing from each other. Certainly, you need to declare this route yourself. That is to say, for dynamic routing protocols. Generally, there is the concept of neighbors. Only after establishing neighbor relationship can we learn from each other. I just said that too. They are hello packets sent every 5 seconds. 15 seconds if not received. The neighbor will fail. The second message is update. Send routing update. It represents 2 dots. The first point is when the device establishes a neighbor relationship. For the first time, all routes will be updated to each other at one time. The first packet is also a packet passed by the router. Because the other party has nothing about me now. Then the message sent to the other party for the first time. It is the content carried by the update message. Secondly, if there is an update in the future, also known as sending routing updates, it is also an update message. Then EIGRP sends the routing table. Give an example to explain the third and fourth. Let's draw a picture. 1, 2, 3, 4. This is 4 devices. Device 4 has a network segment here. Assuming this has an exact address. 4.4.4.4. So now running EIGRP. Device 2 can learn device 4 here. Because device 4 interacts with device 3. Device 3 interacts with device 2. Device 2 has this 4.4.4.4 route. At that moment, device 2 and device 3 were disconnected. Whether it is an interface problem or line problem, they both broke. So first for device 2. The next hop that device 2 originally went to was device 3. So now device 2 will have a consideration. It will think that now because there is a break between the two of them, neighbors fail. 15 seconds passed. It found lost this neighbor. At the same time, it thinks that the relationship between this device and it is broken. And it also thinks it has a problem now. Then this route will be gone. In addition to losing this neighbor relationship, the route to 4.4.4.4 will also be lost. But for EIGRP, now device 2 will not immediately delete this 4.4.4.4 from the routing table. It will give its neighbors who are still send a request message. So now it has only one neighbor left. It will send a message to device 1. It will ask if device 1 has a method path to 4.4.4.4. Then device 1 will reply to device 2 that it does not. If it wants to go to 4.4.4.4, it has to rely on device 2. Then device 2 will send 16 times per unit time. Device 1 needs to reply to it 16 times no. After that, device 2 will delete it. But there is a situation. For example, originally, device 1 and device 4 were directly connected. Then device 2 goes to 4.4.4.4 and goes to the right. This is its optimal path. And possibly for some reason, this route has not been added to the topology table. Then at this time when it is broken, it will query device 1. Is there a route to 4.4.4.4? Then now device 1 will reply that it knows. Device 2 will send the next hop to the route 4. 4.4.4. Pointing to device 1. Then complete the data forwarding. This is called sending a request to a neighbor. Inquire. And the response. This is the interaction between them. Finally there is an ACK. It is not a message. It is a confirmation mechanism. Then in the 4 messages mentioned above, there will be an ACK field. Can be filled with it. That is, all messages of EIGRP provide confirmation mechanism. After the device sends data to the other party, the other party can carry the confirmation. In the message sent to the device, represents that the message between them has been transmitted to. It is equivalent to a confirmation mechanism. When you analyze the message later, you will say, now just to briefly mention to you. Okay. We are about to enter the configuration phase. First turn on these 4 devices. Save some time. Let's go back to what we just said. EIGRP now wants to establish neighbors. Then a